factoring quadratics. Quadratics means that I'm going to have a leading coefficient of 2. It means my degree here is 2. So the first thing I do is I make sure it's in descending order. And I see x squared, x to the first, and then there's no variable here. So it would have been x to the 0 power, because x to 0 is 1, 1 times 6. So it is in descending order, so check. My variable terms is x squared and 7x, or excuse me, negative 7x. My constant term is 6. So if I was to list the variable terms, I have x squared and negative 7x. My constant term is 6. My leading coefficient is going to be whatever degree, or excuse me, whatever number is in front of my variable of the leading degree. So let's talk about that. Leading degree. If this is written in descending order, I can determine what's my leading degree, and the leading degree is 2. Because it's the power of 2. My leading coefficient is 1 in this case here. So I want to talk about factoring. So if we're factoring a quadratic, it needs to be written as ax squared plus bx plus c. And these plus signs could be negatives. I mean, there is possibles of that. And as long as it's written in this format, where a, b, and c are my coefficients, x squared and x is my variables. So my variable term is ax squared and bx. My constant term is c. The coefficient a cannot equal 0 in order to have a quadratic, because if it equals 0, then I wouldn't have x squared, and I would just have bx plus c, which would be linear, right? Bx plus c is linear. So in order to have quadratic, we need the x squared. The rest doesn't have to be there, as long as that's there. If a is a negative number, you're going to factor the negative out. Okay? The sign on C determines to add or subtract the product of A times C that will equal my B. This is the AC method. So let's use this example at the top to do that. Is it written in descending order? Yes. What is my GCF? Well, I see that I have a positive 1. If it was a negative 1, I'd factor negative 1 out. If it's a positive 1, so that means that the 7 and 6, 1 is the only number that will go out of all of them. So my GCF is 1. Next step. Next step says take A times C. Well, what is A? A is 1. C is 6. And we're going to multiply them together, and it gives me a product of 6. I'm going to list my product of 6. I got 1 times 6 and 2 times 3, and this works out great. So I'm going to take the product, of A times C, that what? Well, that adds to get what? To get my B. What is my B? A negative 7. Okay, so we're going to bring down what does not change. What does not change is the first term and my last term. And what I'm doing is I'm going to rewrite the middle term to where it's in terms of 4, so I can factor by grouping. Alright, so I'm going to look at this one. If I take and look at B's negative 7. So that means I need to make it a negative 1 minus 6. And would you agree, if my bank account's in the whole $1 and I spend 6 more, I'm adding those two together and I'm still in the hole? Does that give me negative 7? Well, yes. So that's the terms I want to use. If it didn't, then I would try this next set. So I have negative 1, but I go back and look. That B also has an X on it, so I must put an X with that negative 1. Minus 6, and it has to have an X with it. Now, I'm going to rewrite this cleaned up just a little bit because we don't put a 1 in front of the variable as the coefficient because we know 1 times X is X. So let's just clean this up a little bit better. And would you agree, I did not change the original because negative x minus 6x gives me negative 7. So I have the equation, except for this is in a polynomial form. It has 4 terms. So let's use factoring by grouping. So I'm going to split this in half, and I'm going to just focus on these 2 terms here and worry about the next side here in a little bit. So what I see here is that I have x squared and negative x. So I can factor out an x, right? And if I factor out an x, it's the same as saying let's divide it by x, right? And the quotient rule says if I divide by like bases, I subtract the powers top minus bottom. So 2 minus 1 leaves me with x, right? So I got a negative x and a positive x. And we know when we divide negative by positive, we get negative. And I know x goes into x 1 time. So I've taken care of that side. So next, I'm going to grab this sign here. And it's going to be part of what I factor out. Because remember, I told you, if your first term has a negative sign on it, always factor it out. Well, since we're doing this in sections, this is my first term. We have to factor out the negative. Also look at to see what is my GCF over here. And I see that I got a 6 and I have a 6. So I can factor out the 6. This has an X, but that does not. So my GCF on this side is a negative 6. So when I factor it out, it's the same as saying let's divide each one by the negative 6. Negative divides negative becomes a positive. 6 goes into 6 1 time. 1 times x is x. Negative divide positive gives me a negative. 6 goes into 6 1 time. So good so far. We found the GCF over here, which was x. Found the GCF over here, which is negative 6. And now I have 2 terms. I have this monomial times a binomial minus a monomial times a binomial. This term minus this term. So now I'm going to look for its GCF. And its GCF here is x minus 1. Would you agree that parentheses matches that parentheses? So I'm going to factor it out. Well, when I factor it out, it's the same as saying divide by it, right? Right? I'm going to do this. And when I factor it out, what I'm left with, x minus 6. X minus 6. This is factored form. Now, later on, you're going to be asked to solve for x. So if they ask you to use the zero product rule, or just what is x, there's many ways to ask this, or solve for x. Well, when we get down to this part, all we got to do is take this here, x minus 1, set it equal to 0, x minus 6, set it equal to 0, and solve. Since that's a negative 1, we'll add it to both sides. That's a negative 6, we'll add it to both sides. And this will yield x equals 1 and 6. So this is if and only if you're asked to solve for x.